Hello one and all. In last session, we will discuss this anti-malarial agent, introductory part and the classification of anti-malarial agent along with the life cycle of malaria. And continuation with this or moving towards this, the first class of anti-malarial agent is aryl amino alcohol. The examples are quinine and quinidine and cinchonine, cinchonidine. This is the Cinchona alkaloids, a naturally occurring anti-malarial agent. This alkaloids obtained from the cinchona bark, having this bark contains the 64 alkaloids, but the four are useful for the erythrocytic synthesites against this. This biological source of the cinchona bark is Cinchona officinalis, is the South American tree in the family Rubiaceae. The bark chemical constituent of this bark is quinine, quinidine, cinchonine, and cinchonidine. These are the major constituent of this Cinchona bark. This quinine has a four asymmetric center, that is C3, C4, C8, and C9. Basically, this Cinchona tree produces these alkaloid, and all the antimalarial agents are based on this chemical structure of this alkaloid. The nomenclature of this two series of alkaloids and their numbering system is based on the rubane, and the stereochemistry is differs at the position number 8 and 9 with the quinine and cinchonidine. Historically, this quinine has been the main treatment for the malaria until the advent of the Second World War, when the battle in areas where malaria was endemic led to the search for more effective agents. And the bark of the cinchona tree contains the antimalarial agents. It is a fluorescent compound, that is quinine, and which is isolated from the bark during early 19th century. This quinine is the compound that contributes to the bitter taste and tonic water. This quinine has been used for the fevers in South America since 16,000. The pure alkaloids, that is quinine and cinchonine, were isolated in 1820. The stereoisomers, that is quinidine, is the more potent antimalarial agent, but it is also more toxic. That is less selectively toxic. The quinine is the lethal for all Plasmodium schizones and gametocytes. Now, the chemistry behind this quinine, that is basic skeleton is rubane. This is the structure of rubane. Basically, this is the rubane, that is quinoline ring system, derived from the parent compound rubane, named after the Rubiaceae. That is the Rubiaceae is the family. This is rubane 9-ol, means this is ol. Hydroxy is substituted on this position. That is rubane nucleus is combined skeleton formed from the quinoline ring attached through methylene group to quinucleidine ring, that is a bicyclic ring contains this nitrogen. This is the quinucleidine. This is bicyclic ring contains nitrogen atom, and this rubenol, that is methylene group, is oxidized to a secondary alcoholic group, and the carbon atom becomes asymmetric. The SAR behind this Cinchona alkaloids, this quinine and quinidine, this as already told, this quinine has the four asymmetric center, that is C8, 9, 4, and 3, and this quinidine is the diastereomer of this quinine, while the cinchonine and cinchonidines are the analogues of quinine and quinidine. That is methoxy group at 6th position is not essential for this activity, and configuration at C3 and C4 is also not essential for this biological activity. This quinine and quinidine has opposite configuration at two centers. This is cinchonidine and cinchonines are dimethoxy analogs. There are four stereoisomers, that is quinine and its dihydroform, quinidine, cinchonine and its dihydroform cinchonidine. I repeat again, this quinine, it is methoxy group at this R position, isn't it? This is the methoxy, and also in quinidine methoxy. But in case of this cinchonine and cinchonidine, this R is replaced with the hydrogen. So this is and the quinine, quinidine and this cinchonine, this group hydroxy group at ninth position is on the alpha, and in case of this is the beta, means towards the observer, and this one is dotted line, this one is the wedge line. So this stereochemistry based on this hydroxy group, and this carbon is chiral in nature. This carbon is chiral in nature because four different groups are attached to this carbon atom. This is first hydroxy, second one is this hydrogen, and this whole ring system, and this one is the vinyl group. It is totally different. That four carbon atoms are attached with the carbon atoms are attached with the four different groups. Isn't it? So these are the structures of quinine and quinidine, cinchonine and cinchonidine. This is a quinine structure. Numbering is starting from this nitrogen atom like 1, 2, 3, 4, 5, 6, 7, 8, like this. And at this position 8 and 9, the chiral recognition is believed to take place due to hydrogen bonding groups, and the exchange of quinine for quinidine reverse the retention order for same enantiomers. This quinine and cinchonidine has the absolute configuration, same configuration, and quinidine and cinchonine has the same configuration, that is R, 3R, 4S, 8R, 9S is the configuration of this quinidine and cinchonine. This again, Cinchona alkaloids is the quinine is the L isomer of alkaloid obtained from cinchona bark, and quinidine is the D isomer which is used as antiarrhythmic. So this is the stereochemistry behind this. The D isomer of quinine is antiarrhythmic and L isomer is antimalerial use. An effective erythrocytic sesonticide, a suppressive and used to prevent or terminate the attacks of Vivax oval malaria, and sensitive to this falciparum, less effective and more toxic than chloroquine. Moderately this effective against hepatic form, that is pre-exoerythrocyte and gametocytes. These are the group which is substituted on this R1 and R2. This R2 is the same in all, but R1, that is methoxy in quinine and quinidine, and hydrogen in cinchonine and cinchonidine. This is the R1. Next one is how it is at 8S and 9R. When we consider this 8 position, in case of this, when first, second, third, 4, 5, 6, 7, 8, isn't it? This 8 again, 1, 2, 3, 4, 5. This one is 6, then 7 and 8. This 8 and 9, this 9 one is the chiral carbon, isn't it? So 9 one is chiral carbon, and the configuration of this 9 is depends upon this 2, this above and below the plane. That is, this one is the dotted and this one is the wedge hydroxy group. So when we consider this 9 number carbon, this carbon is chiral in nature, so it having RNS configuration. So this 8 position S at in case of quinine, in case of quinidine it is R, and in case of cinchonidine it is again R, and cinchonidine it is again S. And the 9 position, it is this one is the 9 position, this one is the 8 position, 8 number. So this carbon is also chiral. How it is chiral? Because this carbon is substituted with this nitrogen. Here is the methyl. Here is again a methyl, but this methyl is substituted with this whole total group. So that's why this 8 number is also chiral in nature. So next class is this 4 amino quinolines. That examples are chloroquine, hydroxychloroquine, amodiaquine, and santaquine. I will explain the only one IUPAC of this chloroquine, that is 7 chloro. The numbering system is starting from this again nitrogen 1, this is 2, this one is 3, 4, 5, 6, this one is 7. Like this is 7 chloro, and this N is substituted with this N or this N. When we consider this N, that is 5-diethyl amino, isn't it? So 5 means what? 1, 2, 1, 2, 3, 4, 5. It is diethyl. This is diethyl amino. This is what? Diethyl. This one is the diethyl. This one is the amino at the fifth position of the carbon. This is diethyl amino. Pentane. This is pentane means this is 1, 2, 3, 4, 5. Pentane quinoline 4 amine. This is quinoline, and fourth position is amine. This is the fourth position. This is the IUPAC of this chloroquine. So you can write the IUPAC of hydroxychloroquine, amodiaquine, and santaquine by using this IUPAC. Very simple. That is, it contains the heterocyclic ring quinoline. Seventh position it is what? Chloro. Fourth position it is what? Aminoenol, isn't it? And the pentane chain is there. So it is hydroxyethyl. It is what? Hydroxyethyl. Only the difference in chloroquine and this chain is replaced with this aromatic ring system, that is benzene. So it is also biological activity. So this is the SAR of this very important activity structure, activity SAR. This is the santaquine. Again the variation on this methyl group is substituted on the third position. This methyl group is substituted on the third position. Right. The mechanism of action of this 4-amino quinoline and this quinoline ring system. So hemoglobin is transported into the food vacuoles of plasmodium, where the digestion of hemoglobin is supplies the organism with the source of amino acid. One of the product of this digestion is a free heme, a substance toxic to plasmodium cells, which is the plasmodium vacuole, is polymerized to hemozoin. It has been demonstrated that this quinolines binds to the hemozoin through drug heme complex, isn't it? So in which the aromatic quinoline ring pi bonds to porphyrin nucleus. Pi bonds to porphyrin nucleus. This drug heme complex caps the growing polymer. As a result of this complexation, the newly formed free toxic heme is now present, which leads to the death of this plasmodium. In short, I repeat again this mode of action of this quinoline, 4-amino quinolines. When hemoglobin is hemoglobin is transported into the food vacuoles of plasmodium, where the digestion of hemoglobin supplies the organism with the source of amino acid, isn't it? One of the product of this digestion is a free heme, isn't it? A substance toxic to plasmodium cells. This free heme is toxic to the plasmodium cells, which in plasmodium vacuole. Further, it polymerizes to hemozoin. It has been demonstrated that the quinolines binds to this hemozoin through drug heme complex, in which the aromatic quinoline ring pi bonds to the porphyrin nucleus. This drug heme complex caps the growing polymer. as a result of this complexation, the newly formed free toxic heme is now present, which leads to the death of this Plasmodium species. This is the mode of action of this quinolines, quinoline and 4-aminoquinolines. The structural activity relationship of this 4-aminoquinoline, that is chloroquine, hydroxychloroquine, amidoquine and santaquine. The 7-chloro is essential for activity. 7 position chlorine group is important for biological activity. The side chain at the 4th position, that is dialkylamino, and alkylamino is essential for activity. It should be a 2 up to the 5 carbon atoms between the nitrogen atom, particularly 4-diethylamino methyl butylamino side chain, that is optimum for biological activity. Then tertiary amine is important for biological activity. Substitution of this hydroxy group from one of the ethyl reduces the toxicity and increases the plasma concentration. As example is hydroxychloroquine. The introduction of or replacement of this chain at the 4th position with the aromatic ring system. Example is amidoquine. It is also a biological activity. It shows a biological activity. I repeat again, the introduction of aromatic ring at the side chain gives the compound with reduced toxicity and shows its biological activity. The introduction of an unsaturated bond in the side chain was not detrimental to activity. And the D isomer of this chloroquine is less toxic than its L isomer. This is regarding what 4-aminoquinoline structural activity relationship of this 4-aminoquinoline. That is the 1, 2, 3, 4, 5, 6, 7. The 7-chloro is essential for biological activity. This 1 number, 2 number, 3, 4, 5, 6, side chain at 4th position. At this 4th position, when we chain 5 carbon atom, this is 2 to 5 carbon atoms are it shows a better biological activity. Then tertiary amine is important for biological activity. Then replacement of this alkyl group with aromatic ring system is also biological active compound. An example is amidoquine. It gives the better activity and lays the toxicity than all. Then introduction of this unsaturated bond in the side chain was not detrimental to the activity, and the D isomer of chloroquine is less toxic than the L isomer. This is regarding Cinchona alkaloids and 4-aminoquinoline, the first 2 class of antimalarial agents. Thank you.